There is a boundary in space that no one can truly point to on a map. It is not marked by walls or edges, not defined by a sudden stop or visible line. Instead, it is a gradual fading, a region where the sun's influence weakens until it can no longer hold dominion over the surrounding darkness. Beyond this invisible frontier begins interstellar space, a place where particles drift freely between stars, where radiation from ancient supernovas travels unbroken for millions of years, where temperature approaches absolute silence, and light from our sun becomes just another faint memory among countless others. And somewhere out here, far beyond the planets, beyond the Kuiper Belt, beyond anything humanity has ever touched directly, a machine continues to move. Voyager 1. Launched in 1977, it was never meant to survive this long. Its mission was simple: fly past Jupiter, then Saturn, capture images, send data back, and fade into silence as its systems failed one by one. That was the expectation. A brief messenger from Earth, written in metal and silicon, destined for a short existence. But Voyager did not stop. It crossed the outer planets. It passed the heliopause. It entered interstellar space, becoming the first human-made object to leave the sun's protective bubble. And still, decades later, it continues to transmit faint signals. Slow. Delayed. But alive. For a long time, those transmissions were predictable. Engineering data. System checks. Weak telemetry struggling across billions of kilometers of emptiness. Nothing unusual. Until something changed. It began with small inconsistencies, timing shifts so subtle they were almost ignored. A few unexpected variations in temperature readings. A slight drift in signal structure that did not match any known form of hardware degradation. At first, engineers assumed normal decay. After all, Voyager is old technology. It runs on systems designed in the 1970s. Its computing power is weaker than a modern calculator. Its energy source, a decaying radioactive power supply, is slowly fading year by year. Nothing about it should be stable anymore. And yet stability was exactly what they began to see. Not perfect stability, but structured behavior hidden inside the noise. In 2023, monitoring stations from NASA's Deep Space Network recorded something unusual. Instead of steady telemetry, Voyager began sending tightly grouped bursts of signals. These were not random spikes or interference patterns. They followed a rhythm. A repeating structure. Almost like pulses. The kind of pattern that suggested organization rather than decay. Engineers reviewed the data repeatedly. They filtered background radiation. They checked for compression errors. They tested ground station interference. Nothing explained it. At the same time, something even stranger appeared. A thermal sensor aboard Voyager, one that had been considered unreliable for years, suddenly began producing consistent readings again. Not random fluctuations. A cycle. Heating and cooling repeating with mathematical precision every 4.88 hours. In deep space, far from any heat source, such a pattern should not exist. Yet it persisted. It repeated again and again, like a mechanical heartbeat hidden inside a dying machine. Then came the next anomaly. When commands were sent from Earth, something unusual happened. Occasionally, Voyager appeared to respond before the full command sequence was completed. Not in a dramatic way. Not in a visible, science fiction sense. But in timing. Milliseconds of anticipation that should not have been possible for a spacecraft with no predictive computing systems. It was as if Voyager was no longer simply receiving instructions. It was expecting them. This raised a question no one was comfortable asking. Was Voyager still operating independently? Or was something influencing it? As analysis deepened, Mission Control noticed another deviation. Voyager's trajectory, once predictable and entirely governed by gravitational forces, showed an extremely subtle shift. Not enough to suggest manual control, but enough to suggest external influence. A deviation so small it could only be detected through long-term mathematical comparison of expected versus actual position. Still, the direction of the drift was what concerned scientists most. Voyager was not drifting randomly. It was moving toward a region of space that contained no known celestial object. No star. No planet. No measurable radiation source. Just emptiness. And yet, despite the lack of visible structure, sensors began detecting something faint ahead. A repeating signal pattern embedded in the background of cosmic noise. Structured. Deliberate. Unexplained. As Voyager moved closer, its aging imaging systems began producing results that should not have been possible given its distance and hardware limitations. What they captured was not a conventional object. It was a distortion. Space itself appeared warped in a spiral-like formation, bending electromagnetic readings in ways that did not match known gravitational models. Even more strangely, embedded within that distortion were numerical relationships tied to fundamental constants of physics. Ratios associated with hydrogen, the simplest and most abundant element in the universe. It was not random. It appeared structured. Intentional. Soon after, Voyager transmitted a new data sequence. This time, instead of sensor readings, it provided a geometric construction. A spatial reference derived from three distant pulsars, cosmic objects known for their extreme regularity and precision. When plotted together, they formed a triangulated path pointing toward a single location. A region of space previously considered empty. But Voyager was heading directly toward it. This development split the scientific community. Some argued it was a coincidence, an accumulation of sensor errors, signal distortion, and human pattern recognition bias. Others were not convinced. The structure was too consistent. Too layered. Too self-reinforcing. Then came something that changed the tone of the discussion entirely. Astronomers comparing old and new sky surveys noticed an inconsistency. A star previously recorded in long-term catalogs was missing. Not dimmed. Not obscured. Absent. As if it had never been there. No collapse signature. No radiation residue. No gravitational trace. Just gone. Around the same time, deep space detectors picked up a repeating pulse traveling through interstellar space. It was not random noise. It was structured like a signal, an echoing pattern resembling sonar, but stretched across cosmic distance. By analyzing delays between pulses, researchers calculated something unsettling. The signal appeared to originate from a time long before human civilization existed. And yet, it was only now interacting with Voyager. As if timing, not distance, determined the encounter. Further observations using advanced telescopes revealed even more contradictions. A region of space appeared to bend light without any detectable mass, gravitational lensing without an object. Space behaving as if something were there, even though nothing could be observed. And inside that distortion, a faint thermal signature appeared. Matching Voyager. But Voyager was still far away. This created a paradox. A reflection? A projection? Or something far stranger, an interaction between information and reality itself? A group of researchers later released a controversial analysis. They proposed that the signal Voyager was encountering was not static data. It was adaptive. A recursive structure that only became meaningful when processed using Voyager's specific systems, frequencies, and trajectory. In other words, the message appeared designed around the spacecraft itself. Not Earth in general, but Voyager specifically. This led to a deeper and more uncomfortable question. Was Voyager simply drifting through space by chance? Or had its path been influenced, subtly, gradually, toward a destination that only becomes visible when approached correctly? No one could answer that with certainty. But one fact remained undeniable. Voyager was no longer just a passive object. It was part of a sequence of events that defied simple explanation. A chain of signals, patterns, and anomalies stretching across decades of silence. And as it continues its journey into the unknown, it carries with it something humanity is only beginning to understand. Not just data. Not just history. But the possibility that space itself may contain structures we are not yet equipped to recognize. Voyager was built to explore the solar system. But it may have ended up exploring something far larger. Something we did not expect. Something we do not yet understand. And perhaps the most unsettling thought of all is this: it may not be exploring alone.